Hi, everyone. I guess it's now noon, so we're going to get started. I'm so excited to kick off the series, and thank you to everyone for joining today. My name is Rishika Singh, and I will be starting the Introduction to NLP series today for the Women Who Code Data Science chapter. First of all, I would like to give a shout out to our amazing team of volunteers for putting together this series. We would not have this series without them. All of the panelists are on this webinar, and so for this session, I will be the speaker and all of the other leaders will be present on the chat to support you throughout today's seminar. And feel free to reach out to us with any questions that you may have. And then we have a second shout out, and this goes out to our sponsor, Home Depot, for putting together much needed events for our community. Do show your appreciation for them by retweeting our posts, and Helena will be sharing them on the chat. And so before we begin, any links that we mentioned during this session will be shared in the chat section. So firstly, you can download the slides with this link that's on the slide here. It will be shared in the chat. If you have any questions regarding the content that we're covering in today's session, please post them in the Q&A box. If you see questions that you would like to get answers to, please upvote them so that they get answered with a higher priority. And our panelists will answer the questions in text format. And if you have any issues, please chat directly with the panelists if you're facing any issues throughout today's session. So today's seminar will be NLP 101. The first half of the seminar will be a presentation, and then we will jump into some coding using Google Colab. These slides have been provided to you, and the link to the Colab notebook will be included towards the end of the slide deck. So in between the presentation and the coding, we will take a brief 10-minute break just for everyone to get up and stretch, and then we'll get right back into it. So let's get started. So just to show today's agenda, we're going to go through what is NLP and where is it used. Then we'll go a little bit deeper into the challenges in understanding natural language text. Then we'll go into a brief description of the NLP workflow. And today we'll be focusing on the first two parts of this workflow, which is exploratory data analysis, or EDA, and pre-processing steps. Then we'll do some wrap up and some next steps, and then we will actually be implementing with Google Colab. So what is NLP? So NLP, or natural language processing, is a subfield of computer science and artificial intelligence. It's concerned with the interaction between computers and human or natural languages. It is used to apply machine learning algorithms to text and speech. It allows humans to bypass programming languages to speak to computers and instead use normal human speech. So it basically breaks down the barriers of communication by allowing anyone, whether they have computing knowledge or not, to talk to chatbots, systems, apps, or any kind of software that you can imagine. And we have several applications, and so some of them are text classification, machine translation, sentiment analysis, spam detection, autocomplete, question answering, predictive typing, etc. And nowadays, the majority of us actually have a device that we use on a daily basis. So for instance, Microsoft has Cortana, Apple has Siri, Amazon has Alexa, and there's also Gmail's spam filter. So now we look at the relationship of NLP with data science, artificial intelligence, and machine learning. So machine learning can help NLP-powered systems to adjust actions according to the historical context and the patterns that it picks up in any given conversation. So for instance, if I ask a banking bot to pay my electric bill, and that request happens to fall near the 25th of each month for 3 straight months, then this bot can anticipate my request and then automate the task. So NLP technology is very human-like in this sense, and in the sense that more conversation can actually lead to better comprehension. And so more conversation provides more of a context and allows for this chatbot to pick up on these patterns. Therefore, the bot can better comprehend the user and provide a better user experience. So now to go into a timeline of NLP. So first, we have back in the 1600s, the philosophers Leibniz and Descartes actually proposed theoretical codes in relation to language. Then in the 1930s, there were actually patents that were submitted for quote unquote translating machines. And here is where Ostruni applies to build an automatic bilingual dictionary. Then Peter Troyansky proposes another dictionary that actually processes variations in grammar across languages. Then in the 1940s, machine translation was actually used in hopes to break codes in World War II. And this is when they tried to translate Russian into English, although the results were unsuccessful. And then in 1950, Alan Turing very famously published Computing Machinery and Intelligence, and this is where he outlined the concept of the Turing test. And then in 1957, Noam Chomsky releases the Syntactic Structures, which advances linguistic studies with a universal grammar rule. Moving on, then in 1966, we have Eliza, which is a computer psychotherapist, and it is actually the first bot. And then we have in 1968 to 1970, SHRDLU, which is an early NLP program, which is developed by Terry Winograd at MIT. And this allows computers and people to converse. However, there are some restrictions. Then we move on to 1970 and 1980. And Roger Schenck actually introduces conceptual dependency theory for NLP. And William A. Woods, he releases the Augmented Transition Network to show natural language inputs. And again, a wealth of bots are actually written in this time period, including Perry. And then we move to the 1980s, and here the first statistical machine translation systems are developed. And the strict and complex handwritten rules are actually swapped for these newly developed algorithms, which drastically increase computers' understanding. Then in the 1990s to 2000s, programmers developed models to increase the capabilities of computers using natural language processing. And then in 2006, we have IBM, which creates AI software. And this is Watson, and Watson goes on to win a competition against the best human contestants in 2011. Then in 2010 and 2020, people continue to introduce technologies that utilize NLP into their homes. And this is, as I previously mentioned, we have the mobile assistant Siri from Apple in 2011. Amazon introduces their assistant Alexa in 2014. And 2017 actually marks this rise in chatbot integration into business operations. And now from 2020 and moving into the future, we see that there's these rising adoption rates of AI-powered bots for customer-facing roles. And we see that NLP will continue to develop so that communication with computers will be as effortless as human interactions. And now to see where is NLP used. I'm just going to give a brief overview of all the different industry applications, and we'll be actually covering a few of these. So first we have machine translation, which is the task of automatically converting one natural language into another. And in doing so, you're preserving the meaning of the input text. And the hope is that you produced fluent text in this output language. So while machine translation is one of the oldest subfields of artificial intelligence research, there is this recent shift towards large-scale empirical techniques, and this has led to drastic improvements in translation quality. However, there are still several challenging aspects of machine translation, and I'm just going to go over 3 of these. So first, there is this large variety of languages, alphabets, and grammars. Next, we have the task to translate a sequence to a sequence like a sentence is actually harder for a computer than working with just solely numbers. And lastly, there's no one correct answer. And if you're translating from a language without gender-dependent pronouns, he and she can then be the same, and this leads to other complexities. Next, we have text classification. So here, this is a process of assigning tags or categories to text according to its content. And these text classifiers can be used to organize, structure, and categorize pretty much anything that you can imagine. It is one of the most fundamental tasks in NLP with broad applications such as sentiment analysis, topic labeling, spam detection, and intent detection. For example, new articles can be organized by topics, or support tickets from IT can be organized by urgency. Chat conversations can be organized by language. Brand mentions can be organized by sentiment, and so on. And text classification can be achieved in two different ways. This is manual classification and automatic classification. So then the manual process, a human annotator is actually interpreting the content of the text and categorizes it accordingly. And this method can usually provide quality results, but it is very time consuming and expensive. Secondly, we have automatic classification. And this is where you're applying machine learning, NLP, and other techniques to automatically classify text in a faster way. And it's much more cost effective as compared to manual classification. Next, we have sentiment analysis. And this is contextual mining of text, which helps to identify and extract subjective information in any source material. And it is the most common text classification tool that analyzes an incoming message and tells whether the underlying sentiment is positive, negative, or neutral. So this allows businesses to identify customer sentiment towards products, brands, or services through online conversations and through feedback. And sentiment analysis models focus on polarity. So this is like positive, negative, or neutral. It also focuses on feelings and emotions like angry, happy, sad, etc. And even on intentions, for example, interested versus not interested. So how does it actually work? So we have two stages. First, we have the training stage and then the prediction stage. So in the training stage, the model actually learns to associate a particular input, for example, a text, to a corresponding output or a tag. And this is based on the test samples that are used for training. Then the feature extractor actually transfers the text input into a feature vector. And so then we have these pairs of feature vectors and tags. These tags are, positive, negative, or neutral. And this is then fed into the machine learning algorithm to then generate a model. Then in the prediction stage, the feature extractor is actually used to transform unseen text inputs into feature vectors. And then these feature vectors are then fed into the model, and this helps to generate predicted tags, again, positive, negative, or neutral. So those are some applications of, and just a brief overview of where is NLP used in our world today. Then I will be, let's see. Let me just reshare this. Okay, I'll just share it from here. It seems like the full screen is not quite working, but so for NLP in our everyday lives, many of us have, virtual assistants, whether it's in the form of an Amazon Echo or Google Home. And these, have enjoyed being able to, we have enjoyed being able to interact with them or through a computer. And this is a very nice conversational interface. Many businesses are actually also exploring how these conversational interfaces can be transformational because the technology is very platform agnostic. It can continuously learn, and it also offers customers a frictionless experience. NLP is behind the scenes for several things that you may not even notice. So, when you ask Siri for directions or to send a text, NLP is actually enabling this functionality. So here are some, just some more applications of NLP. So we have the email assistant, so autocorrect, grammar, spell checking, as well as autocomplete are all functions that are enabled by NLP. The spam filter that you have on your email system actually uses NLP to determine what emails you'd like to keep in your inbox and what are likely spam and just should be sorted out. Also, when you're answering questions, so if you have ever shopped online or interacted with a website chat box, you likely were interacting with a chatbot rather than a real human. And so these kind of AI customer service gurus actually are algorithms that use NLP to be able to understand your query and then respond to your questions adequately, automatically, and in real time. Next, I'm just going to go over some amazing applications of NLP. So first we have the Livix app, which is actually a communication device for people with disabilities. And this was the creation of Carlos Pereira, who is a father who actually helped to develop this app for his nonverbal daughter who actually has cerebral palsy. It allowed him to communicate with her. And it's a very nice customizable app, and it's actually available in 25 languages. Then we have Sign All, which is another tool that's enabled by NLP. And this helps to convert sign language into text. And this can help individuals who are deaf that are trying to communicate with those who may not know sign language. Then we have, as I mentioned, machine translation is a very popular application. And this allows us to overcome barriers when we're trying to communicate with individuals from around the world. So Google Translate is a very widely used example of this. It's used by 500 million people every day to then understand more than 100 world languages. Then it's also used in aircraft maintenance. And so you can, not only could it help mechanics kind of synthesize information from enormous aircraft manuals, it can also help to find meaning in the description of problems that are reported verbally or handwritten from pilots or other individuals. And lastly, while this issue is very complex, there's even work being done to have NLP assist with predictive police work to specifically identify the motive in crimes. So let's see if full screen will work now. Not quite. Okay, I think I'll just continue here. All right, I did have a picture here to show, but I'm not sure why it's not showing up right now. Maybe I'll come back to it later in the presentation if it'll show up. But now we will be going into challenges in understanding natural language text. And so I'm going to be going over 4 main challenges. And the first one is ambiguity. So ambiguity is an intrinsic characteristic of human conversations, and it's one that is particularly challenging in natural language understanding. Scenarios by ambiguity, which they are essentially referring to sentences that have multiple alternative interpretations. So the spectrum of what can be considered ambiguous on any language also varies greatly depending on the speaker. And from a technical standpoint, any sentence in a language with a large enough grammar can have alternative interpretations. So there are many different forms of ambiguity that are relevant in natural language and in artificial intelligence systems. So first we have lexical ambiguity, which represents words that can have multiple assertions. For instance, in English, the word back can be a noun, as in backstage. It can be an adjective like backdoor, or an adverb, back away. Then we have syntactic ambiguity, which represents sentences that can be parsed in multiple syntactical forms. For example, in the sentence, I heard his cell phone ring in my office, the propositional phrase in my office can be parsed in a way that modifies the noun or in another way that actually modifies the verb. Next, we have semantic ambiguity, and this is typically related to the interpretation of a sentence. So for instance, going back to the previous sentence that I used, the previous point, it can be interpreted as if I was physically present in the office or as if the cell phone was physically present in the office. And lastly, we have metonymy, which is actually arguably the most difficult type of ambiguity because it deals with phrases in which the literal meaning is different from the figurative assertion. For instance, when we say, oh, Samsung is screaming for new management, we don't mean that the company is literally screaming. This is obviously a figure of speech. And in AI theory, the process of handling all of these different kinds of ambiguity is called disambiguation. And to solve this problem, NLP offers several methods, such as evaluating the context or introducing POS tagging, which is parts of speech tagging, which we'll actually get to that later in this presentation. And understanding the semantic meaning of the words in a phrase does remain an open task, and it is quite a challenging task as well. Next, we have synonymity. So this challenge arises from the fact that we can express the same idea with different terms, which are also dependent on the specific context. For example, big and large can be synonyms when describing an object's size or a building size, but they're not exactly interchangeable in all contexts, since big can mean older, grown up when you're talking about your big sister, while large cannot just be replaced with big in that sentence. And it would not make sense if you were to just substitute large for big in that particular example. And in NLP tasks, it is necessary to incorporate the knowledge of synonyms and different ways to name the same object or phenomenon, especially when it comes to tasks that are more high level and that are mimicking human dialogue. Next, we have co-reference. So co-reference resolution is actually the process of finding all possible expressions that may refer to the same entity in a text. It is a very important step for a lot of higher level NLP tasks that involve natural language understanding. And some examples of this are document summarization, question answering, and information extraction. It has been notoriously difficult for NLP researchers for decades, and it's actually been revived very recently with the advent of cutting edge techniques like deep learning and reinforcement learning. And currently it has been argued that co-reference resolution may be instrumental in improving the performances of NLP neural architectures like RNN and LSTM. And so lastly, we are going to go into the syntactic rules as the last challenge. So knowledge about the structure and the syntax of language is helpful in many areas, such as text processing, annotation, and parsing for further operations, such as text classification or summarization. So there's a few different parsing techniques that are very typically used for understanding text syntax, and they include the following. So first we have parts of speech or POS tagging. Then we have shallow parsing or chunking. Then we have constituency parsing, and lastly, dependency parsing. And this sentence over here will be used as an example for these four techniques. So first we have parts of speech tagging. So parts of speech or POS are the specific lexical categories to which words are assigned. And this is based on their syntactic context and their role in any given phrase or sentence. So the process of classifying and labeling these POS tags is referred to as parts of speech tagging or POS tagging. And these tags are actually used to annotate words and depict their parts of speech, which is extremely helpful to perform specific analysis, such as narrowing down upon which ones are the most prominent. It also helps with word sense, disambiguation, and also grammar analysis. So in this example here, we see the brown fox is quick and he's jumping over the lazy dog. So here we have, so the refers to DET, which is a dependency tag. Then we have brown, which refers to ADJ. Then we have fox, which is like a noun. Then we have is, which is V for verb. Then we have quick again as an adjective. He here is a pronoun, so PRON. Then we have over, which is a very common adverb, so ADV, and so on. So this is kind of how the tagging will happen. Then we have shallow parsing and chunking. So shallow parsing, which is also known as light parsing or chunking, is a very popular natural language processing technique of analyzing the structure of a sentence to break it down into its smallest parts, which are basically our tokens such as words. And then we group them together into these higher level phrases. And so this includes parts of speech tags as well as phrases from a sentence. So this is a picture depicting kind of the parts of speech tag that we used from the previous slide and how we try to break it down into its smallest constituents. Then we have constituency parsing. And so constituent-based grammar is actually used to analyze and determine the constituents of a sentence. And so these grammars can be used to model or represent the internal structure of sentences in terms of this hierarchical structure. And this is the hierarchical structure of the constituents. And so each and every word actually usually belongs to a specific lexical category, and it forms the head word of different phrases. And lastly, we have dependency parsing, and we try to use dependency-based grammars to analyze and infer both the structure and the semantic dependencies and the relationship between tokens in a sentence. So the basic principle behind a dependency grammar is that any sentence in the language, all words in that sentence except for one have some relationship or dependency on other words in the sentence. The word that has no dependency is actually called the root of the sentence. Typically, the verb in the sentence is taken as the root. This is typically done in most cases. And then all of the other words are either directly or indirectly linked to this root verb. And this is done using links. And these links are the dependencies. So you can see how we have these dependencies in the sentence. And you can see from the previous slide here, we have the root, which is typically the verb in the sentence, and then everything else has dependencies and links to that root verb. So that's as far as the challenges that we have in understanding natural text. And now I'll be going into just a brief description of workflow that we see for any NLP task. So typically any NLP-based problem can be solved by a methodical workflow that has a sequence of steps. So we usually start with a corpus of text documents, and we follow different standard processes of text wrangling and pre-processing. And then we also go into some text parsing and exploratory data analysis. And based on these initial insights, we usually represent the text using relevant feature engineering techniques. And then depending on the problem at hand, we either focus on building predictive supervised models or unsupervised models. And these usually focus more on pattern mining and grouping. And then finally, we evaluate the model and the overall success criteria with the relevant customer or user in mind, and we finally deploy this model for future usage. So this entire series will be covering through these different steps in the workflow, and today we'll be focusing on these first two steps, which is text preprocessing, and then we're going into exploratory data analysis, or EDA. All right, so now we have, just to give you a brief overview of the preprocessing in EDA. So for EDA, we're going to be just doing a simple description of the data, looking at some information of the data, as well as a basic visualization. And then for pre-processing, we'll be using Google Colab, as I mentioned at the beginning of the presentation. So first we have noise cleaning, then we have tokenization, then we have spell checking, then we have contraction mapping, then we have stemming and lemmatization, and lastly we have stop words identification. And so these 6 steps will be used for our pre-processing, and that'll be the last stage of our implementation before next week's session. So now I'll go into exploratory data analysis. So just for a goal and overview of EDA. So this is the process of exploring data, generating insights, testing hypotheses, checking assumptions, and finally revealing any underlying hidden patterns that might be in the data. And through these goals, we can get a basic description of the data, we can visualize the data, we can identify any patterns in it, identify potential challenges of using the data, etc. So for our implementation, we will be using this data set, which is a SMS Spam versus ham data set. So it actually comes from the UCI machine learning repository, which is a very commonly used repository for open source data sets for all varieties of machine learning tasks. And so this data set is a public collection of SMS labeled messages that have been collected for mobile phone spam search. And there's a link here just for more information on the data set. And then when we go into describing the data, this is just a basic description of your data. And this covers a broad spectrum, and typically depending on what your specific task is at hand, we might be looking for specific information about the data. So you can kind of interpret this as a very quick and dirty way to get some information on your data, And this is a way of getting some very simple, easy to understand information on your data, or just to get a basic feel for your data. And lastly, something that's very commonly used is word clouds. So as you can see here, this is a word cloud just on different parts of NLP, different concepts, different tasks in NLP. And typically the larger the word, the more frequently it's actually observed in any data set or any data file. So this kind of gives you a very nice visualization of the data set, and shows you what are the most important words, what are the most frequent words. Next, we'll go into data information. So there's a whole variety of things that we can try to extract for this stage. But typically we look at the number of training versus testing instances. We try to see if there's any missing data or perhaps any missing labels of instances. And we might even want to see if there's multiple dimensions of the data. So if there's, what constitutes the rows, what's in the columns. So here's a screenshot of the SMS Spam data set that I referred to, and we'll be, implementing this in the second half of the seminar. But this kind of just gives you a count of, 0 versus 1 are just basically the two different columns of spam versus ham. Basically, how many are unique, what is at the top of the data set. You can also look at what's at the bottom, and then also the frequency of the two different columns. And then next we have basic visualization. So this could be, like a word cloud, like I mentioned, and this generally helps with identifying patterns in the data. And there are two very commonly used Python libraries, which are Seaborn and Matplotlib. And these are very easy and quick ways to achieve this, basic visualization. So here's an example of if we had a data set of different reviews that were given by different users. Here's kind of just a distribution of the rating on the x-axis, and then we have the count on the y-axis. So basically, what's the count for how many people rated 1, 2, 3, 4, and 5. And then here we have some demographic information. So we actually have the age of these reviewers. And this is kind of just a very basic histogram showing the age from 0 to roughly close to 100. And then the count on the y-axis. So basically, how many people are of a certain age. So here between 30 and 31, we actually have 931 reviewers that are of that age. So this kind of basic visualization kind of helps to inform, what exactly do you want to do with this data? Because there's only so much you can do just by looking at the data set and just the text within it. Visualizations help you to identify any patterns, and what kind of additional information can you extract from these patterns. Next, we'll go into pre-processing. So this is the second stage of the NLP workflow that I described. So for this noise cleaning, sorry, just give me a second. So for pre-processing, there are actually many feature engineering strategies that we have for trying to transform any text data into features, because these features are actually what needs to be fed into our machine learning model. And so some of these might be assigning unique word-like terms to a feature. Some of them might be counting the number of occurrences per training example. But if you want to, perform the strategy right now without any pre-processed data, we might end up with like an absurd number of features, and there might be, several complications just from that. And the classifier for our model might actually take way too long to train, and it'll likely overfit as well. So as a result of all of this, every NLP problem that you come across, it does require this tailored approach to determine which terms are relevant, which terms are meaningful, and given this is where we begin our pre-processing. So the first stage is this noise cleaning, and this is where we typically remove any white space, any special characters, and typically there's a lot going on in any sort of raw text data. There's all varieties of punctuation. Some terms might be randomly capitalized. Sometimes some words are in all caps. So there's these countless ways that raw text data might appear, and we need a way to ensure that each training example is on equal footing. We basically have this normalization process. So in this example here, we have one column with the raw words and one column with the cleaned words. So on the left-hand side, you see essentially the cleaned words are all the same word, trouble. But in the first column, we see there's, 2 dots in the beginning, 2 dots at the end, or we see this special character here at the end of the word, or we see an exclamation point, or we see a few more special characters. And here we even see a digit with another punctuation mark. And so basically this clean word will remove all of this unnecessary white space and punctuation, special characters, and at the end we get this nice and clean text. Next we have tokenization. So when we'll be implementing this, we'll actually be using NLTK, which is a very common library that's used for NLP tasks. And this is where we are essentially constructing the features that I mentioned. So we basically break apart the entire text into this vocabulary of unique terms. And this entire process is called tokenization. So we kind of tokenize these individual terms, and we kind of generate what's typically called a bag of words model. And again, we'll be using NLTK, which is the leading platform for building Python programs to work with human language data. So in this case here, we have the sample text of, hi, I would like to tokenize this sentence. And once this is kind of our input, and then our output looks like the same exact words, but each of them is individually tokenized with these enclosed in these quotation marks. And although there is this punctuation mark, the comma here, typically that is removed as a part of the noise cleaning process. So that's why we don't actually see it appear here. And that's typically done because that comma is not essentially, might not be adding any necessary or vital information. So typically that is removed when tokenizing, but at times it is, it is kept when tokenizing. It does depend on the specific task, but generally it is removed when going through tokenization. So then we have spell checking. Spell checking is obviously very important because there might be random words in this raw text that might be misspelled, and we do want this consistency, we want this normalization for our data that we want to feed into our model. So here's a very simple example showing that we have, these are some words, something is happening here, and clearly we can see that this word happening is not spelled correctly. And so we will actually be using, Microsoft has a spell checking system that is very easy to install and import. And from there, it is actually able to recognize happening as the misspelled word. And it does recommend a correct spelling of the word. So this is just another step of pre-processing, and it helps to remove any mistakes that might be in the raw text. Next, we have contraction mapping. Contractions are words that we typically write with this apostrophe. For example, here we have its, and some other examples are like aren't or ain't. And since the whole process, one of the biggest goals of pre-processing is to standardize our text, it does make sense to expand these contractions. So here what we're doing is we're expanding it apostrophe s into it is. And this is something that we'll be, again, implementing in the Colab notebook. And this helps to standardize our text data. And this is the fourth step of pre-processing. And next we have stemming and lemmatization. So the idea of stemming is actually to reduce different forms of possible words being used from it. And we reduce different forms of a word being used, and we reduce that into its root word. For example, here we have the original word is connect, connected, connection, connections, and connects. But obviously the stemmed word here is just all connect. Another example here, we have trouble, troubled, troubles, and troublesome. And this all comes back to trouble. And so this helps to remove any possible variability that we might have in our text data. But if we were to compare stemming versus lemmatization, stemming is definitely the less complicated method, because it typically doesn't produce any dictionary specific morphological root of the word. So in other words, if you were to stem the word pies, sometimes it might produce the root pi, pi, whereas lemmatization will actually find the morphological root pie. So as you can see here, for trouble, it actually is taking off the E for some of these. But in lemmatization, it actually retains the true word trouble, T-R-U-B-L-E. So when we're implementing in Google Colab a bit later, we will actually be using lemmatization in place of stemming, just because it's able to execute this process a bit more accurately. And lastly, so our last stage of pre-processing is stop word identification. So some words in the English language, while necessary in the sentence, they might not contribute much to the meaning of any phrase. Some examples of these are is, so, the, of, or when, or those, or before. And these are all stop words, and they should be filtered out. And so again, we'll be using the NLTK package that I mentioned earlier. They have a library that is specifically contains all of these very common stop words. And basically it goes through the entire text file that we have, and it removes all of these stop words. So first it identifies it, and then it removes it. And again, this helps with standardizing our data and making sure that it's ready for it to be used for our model. So now that we have finished kind of the theory portion, the next portion is the implementation part, where we'll be diving into a Google Colab notebook and going through the exploratory data analysis and the pre-processing that I just went over, but we'll actually be doing it hands-on. And just before that, I just want to do a quick recap of what we went over. So in this, going back to the same workflow, we actually will be going over pre-processing and EDA, and further sections of the series will be going into representation, modeling, deployment, and further on. And so this is the Google Colab project. This is the link to this project. And so I mentioned that we'll be taking a quick 10-minute break before jumping into the implementation. I just want everyone to get up and stretch, get a drink of water, and then we'll be back in 10 minutes. So I guess right now it is, for me, I'm in Pacific Standard Time, so it's almost 12:43. So perhaps we can return at 12:53, and I'll be back on here, and we'll jump into the implementation. And I'll be taking a look at the chat and the QA, and thank you to all the other panelists for helping with all the questions. And thank you everyone for being here again, and I'll see you in 10 minutes. Thank you. All right, hi everyone. So hopefully everyone's back from that 10-minute break. And now we will go into implementing what I just talked about. So we'll be using that SMS data set as well as going into some exploratory data analysis and pre-processing. So the link to this notebook has been shared in the chat. It's also right here on the slides. And so I'm just going to go ahead and switch over to the notebook. Let me just share the screen. All right, so is everyone able to see this? This is our Google Colab notebook that we'll be using. Just pull something up here. Okay. So this is our Google Colab notebook, and I'm not sure how many people are familiar with Google Colab, but traditionally Jupyter Notebook or Google Colab notebooks are used for loading in data, doing different things with data, pre-processing, all of that. And so Jupyter Notebook is something that we use locally on our computers and for purposes of sharing, and it just makes it a little bit easier with Google Colab Notebook because you can share this very easily through other accounts. It's stored in your Google Drive. And there's fewer permissions and all of that. So we will be going into this notebook now. So as I said, we'll be looking at this data set. And so let me just click over to that. So this is a data set. So here we have a parent directory and a zip file. So I'm actually going to walk through the process of downloading this data set and how we actually want to use it in our notebook. So if you click this link here, it will download the notebook. And now it will be in our downloads. And now once we go back to this notebook, so this was a zip file. Basically, when you download it, it gets unzipped. And now we want to be able to load this data set into our notebook. So what we do here, we will actually, let me see, I think it's taking some time to load. Okay, so here on the side, we have this like navigation pane on the left-hand side. So on the top here, we have the table of contents. It just goes through kind of everything that we have in this notebook, and it's very clickable. So you just go here, it goes to the top. And right now we're in the exploratory data analysis section. Next, this is just showing some code snippets. That's not too important right now. And now we will actually be looking at the files. So here, since we have this data set downloaded, we will actually just do a right click here and we will say upload. And so now what we can do is go into downloads and we can very easily search for our SMS data set. Just give me a second here. Okay, so now we go into our downloads and this is our entire data set. And now we want to, there's a README file basically just gives some more information about the data set, but what we actually want is this SMS spam collection. This is a text file. So basically we just open it and now it will be downloaded here. So this is our data set that we'll be using. And so now that we have it all fully loaded, let's move on to the coding part. So now it's time to implement. So first we'll be importing the pandas package, and typically we import that as PD. And so that's something that we'll do right now. And pandas is another very important library that helps for us to load in data, do some data wrangling. It helps us get a deeper look into the data that we have at hand. So since this is a text file, we'll actually be using the read CSV function, which is a function for pandas, and this will be used to load in our data. So we can add in a direct URL to the data set, but since we already have it loaded here, it makes it far easier to just directly refer to it in our file section here. So what we'll be doing is first, we will be calling it as a variable SMS just to make it easier so that later in our implementation, we can just refer to our data as SMS. Then PD is just for pandas, and here we'll be reading it in, and we'll be using, so this is directly referring to the file that we have here. So the way that Google Colab works is that any content that is here, it's under this directory called content, and then SMS spam collection is just the name of our file. And this header equals none is actually used so that the first row of our data will not be interpreted as the column names for the data frame. We don't want that confusion. So next, to see what data we loaded in, we can simply do this below, where we do print SMS. So this print SMS will basically show us, okay, what is actually in our data. So let me just run that cell. I'll just be reading in our data.
Rishika, sorry to interrupt. Could you go back a little bit and show how to open the link that we shared, the Google Colab, the GitHub link, how to open the GitHub link in Google Colab?
Yeah, okay. Let me just see where that link is. Okay, let me just switch over to okay. Sorry for that confusion. So once you click on that link, it'll open up in GitHub. And so this is it's basically the entire notebook file. And so there's several ways for you to open this up in Google Colab, but what we can do is actually, let me see here. Just give me a second. Sorry, just having a couple loading issues. Just give
Hey everyone, sorry for the pause. We seem to be having some technical issues. I'm just going to quickly share my screen and show you how to do the setup of Google Colab to the GitHub, because we will usually share the GitHub link. Once I show this, I think Rishika can pop back in and continue running the code that she already started running. So let me share my screen to start off. Okay, perfect. So this is the GitHub URL that we shared with you all. I think you can take a look in the chat if you don't have access to this link. One of our leaders should share it with you. So this is the notebook that we have. And I'm going to show you the steps to follow if anyone shares any GitHub link with you, how to create an own copy for yourself on Google Colab. So first thing we need to do is go to Google Colab. And that I'm just doing by doing a simple Google search and opening up the first link that pops up. Once you do this, you have multiple tab options over here, as you can see. And our goal would be to go to GitHub. You don't need to give access as of now, since it's a public repository. Enter the URL of the repository and hit enter. And it basically opens a copy of it for yourself, which you can edit, run it yourself, and all of that fun stuff. So over here, all you would do is go to File and save a copy in your own drive, so that you have a copy which you can edit and make changes on your end. So I hope this was helpful to see how to use the URL that we've provided in the chat to open a own copy on your end and save it to your own drive and make changes over there. Yeah, I hope this was helpful. I'm just going to stop sharing now and pass it back to Rishika so she can continue walking us through the steps. We're just going to give you all about a minute so that you can set this up if you would like to follow along with Rishika.
All right. Hi, everyone. Sorry, my screen froze and there were some technical difficulties, but hopefully everyone, thank you, Samantha, for your help with that. Hopefully everyone is able to now access the Google Colab notebook on their own devices. And hopefully you can follow along as I'm implementing and working on this text. So I will now go back to sharing the notebook, and just give me a second. Let's see. Okay. All right, so hopefully everyone is able to see this, and let's see. So now let me go back to where we were. So I might just go back a couple steps just so everyone can catch up if needed. So Pandas is a very popular package that's used, and so before we want to be able to use it, we do have to import it. So we will import Pandas, and typically what's done is that you import it as PD, so that any time that you're using Pandas further in your code, you can simply just refer to it as PD, and it's just kind of a convenience thing. So to run anything in Colab, you basically, this is a text cell and this is a code cell. So to run any of this of these code cells, you basically press this play button. You can also press Command or Control Enter, and that will execute whatever code is in that cell. So now that we have imported Pandas, let me check something. Okay, so as I said, so we will be, we already have our text file here loaded in, and now we just have to load in this data into our notebook. So the way we do this is we again will be using Pandas, and you can use the read table or the read CSV function. And this is a very simple and nice way to read in the text file that we have. And we will assign this to a variable SMS. And again, this is a convenience thing so that later in the notebook, when we want to refer back to our data, we can simply just refer to it as SMS. So we say SMS equals to Pandas, and we have this our function. And this in quotes here is actually the location of our text file. And this is so that Google Colab will know where to look for our data set. So this is our text file, the SMS spam collection data set that I mentioned. And the way that that Google Colab stores any files is actually in this content directory. So in this content directory, inside that, here we have our SMS spam collection. So let's see. So I'm seeing there's a couple issues with finding the file. So the way that we want the file, before we want to use the file, we actually do have to upload it into this file system that we have here. So let me actually go a couple steps back. And this URL that we have here, this is where the data set actually is. So if you click on that link, then this is a zip file that actually contains the text file that I'm referring to. So if you click on that, then it will download it. And then once you download it, it will automatically unzip that file. And as you can see, it's in our downloads folder. So next, what we want to do is go back into our file system, and then we click upload. And then it will, we want to go back into our downloads file. And then what you want to do is look for SMS spam collection, because that is the name of our file, our folder that we downloaded. And then in here, we have two files. The README file is typically a text document, just some information on the text file. It's very commonly done. You can see that on a lot of GitHub repositories. It just helps for anyone who doesn't know about any code or any text file. Just gives them some information on what exactly will they be working with. So we don't want to use this for our analysis. What we want to use is this SMS spam collection. And as you can see, it's a text edit document. So then we click open, and it will now upload that into our file system. So now hopefully everyone should be able to upload this file into their system, and that might fix any errors that people might be having with a file not found error or anything. So I'm hoping that clears that up. So now that we have that in our file system, we can run this cell. And we actually use this here is header equals none. And that's actually so that when Pandas is actually going into this file system and is looking through this data set, it will actually make it so that the first row in the data, it won't be interpreted as the column names of the data frame. So if we don't specify that, then the first row will actually Pandas will assume that it's the column name, but we don't want that in our case because we actually don't have any column names already in this data. We actually will be adding those column names a bit later in this notebook. So now we have it loaded in. I hope everyone is able to get that file working. And next we will be, we just want to see, what is the data, what data are we working with? We want to load it in. So here we're just going to do a simple print and then SMS, since that's the name that we have given to our data. So this kind of gives you just a brief look at, what is our data. So in column 0, this is ham or spam. So this is actually spam is, any sentence that the system thinks is a spam SMS, and ham is basically a normal text, not a spam text. And so column 0 contains ham versus spam, so kind of this classification. And then the column 1 is the actual text itself. So as you can see, we have 5,572 rows. So that's actually how many different individual sentences we have. And then we have the 2 columns. And so then SMS.head. So this .head is another part of, now that we have this, text in this data frame for Pandas, and we want it as a data frame because it makes it far easier to work with. And so this .head actually will just give the top 5 rows of the data. So it's basically the same thing that you see here, but just kind of in a nicer, clean format. So now we will begin some exploratory data analysis. And so the first step, as I mentioned in the theory part, was describing the data. So this is kind of just a very basic description. And so what you can simply do is do sms.describe. And this will give you, this is what was shown in the slides. And this basically will give you, for the two, we have the count, we have the number of unique values, we have the top value, which basically gives you the first row in the data, and then as well as the frequency. So you can see that this, right now you can actually add more components to the .describe, but you can also add in kind of the count, the mean, the standard deviation, the minimum values, the maximum values. And since we're working with text data, there's not you know, the numbers, there's no numbers themselves or digits there's no quantitative values in the text itself. But that's just, you know, that's just the case that we have here for our data. And next we have the data info. So since we have this whole collection of data, we have 5,572 SMS messages. They're all written in English. And so here you can see is that for ham, we have 4,825, and for spam, it's 747. And so the way we actually go about doing this is we will assign SMS 0, and that is basically looking at so we're basically trying to find out, this SMS 0 here is actually looking at the first column that we have here. And then if we were to do SMS 1, that would look at the second column that we have here. So this is basically, from that, we basically do .value underscore counts. And that basically is the way that we are able to get a count of how many are spam texts and how many are ham or non-spam texts. And as you can see, out of the 5,572 SMS messages, 4,825 are not spam, whereas only 747 are spam. And as you can see, there's a very clear imbalance in our data. And that's actually not something that we want, because that might lead to you know, some results that are not very accurate. And so typically we want data sets that have very balanced data. And so, you know, this wouldn't be the most ideal example of a data set. But once we finish up this implementation, I'll actually list out some other data sets that are very commonly used for, you know, basic NLP tasks. And those will be far more balanced and might be a little bit easier to use. So next we will be looking at, so given the ham versus spam, we actually want to kind of categorize these into these class labels. So we're going to be setting spam as 1 and then ham as 0. And so what we'll be using is scikit-learn. And scikit-learn is another very useful machine learning package. And so before we want to be able to use scikit-learn, we do have to, again, import it. And it's actually called sklearn. So in our code here, we're going to say from sklearn import preprocessing. So preprocessing is a library in scikit-learn. So we actually want to import that from scikit-learn. And then we will be using label encoder. And this is a function of scikit-learn. And this helps to kind of encode spam and ham into their target labels. So using this, we will be actually assigning all of the spam text as 1 and then all of the ham text as 0. So what we do here is LE, just to make it simpler, since preprocessing.label encoder is such a long thing to type out, we will basically just assign that as LE so that it's much more convenient to reuse. And then Y underscore E and C is basically this encoding that we're going to be doing. So the way that we want to use this is we do Y underscore E and C. And we'll be using this label encoder to then do a fit transform and on our Y. And on our Y here, as you can see, is this SMS 0, that first column that we have there. So then you will see that in when we print out, just make sure I might not have run that cell. Okay, so we're going to be importing that, and then we're going to be doing a fit transform. And lastly, when we print out this y_enc, which is basically the encoding of these target labels, now what we get is this array. And this array will just be a series of zeros and ones, basically saying, you know, spam or ham, spam or ham. So as you can see here, 0 is ham and spam is 1. So in this array here, the first one is a ham text. So basically it's not a spam text. Again, the same thing. And then we have spam. And this is not, you know, printing out everything since we have, you know, over 5,000 values. This just gives you just a nice look as just to make sure that, you know, the encoding that you're doing is actually working. So now we will be actually placing all of this message data into its own table. So to do this, we have to actually convert this entire text into numerical features that will be useful, because next, you know, we would want to, you know, train the classifier and all that. We won't be doing that today, but that's just something that is typically done before any training. So what we'll be doing is that we'll take this raw text and we will say SMS1. And so this is basically all of the actual texts themselves. And this is just basically converting into raw text. And so I see a question about what is a target variable here. So as you can see, SMS0 that's up here is actually the classification task that we're doing is ham versus spam. And in our original data, as you saw, the first column was either ham or spam. So we're basically, the target variable is, we're basically going to be encoding ham or spam as either a 0 or a 1 value just to make it easier to work with. And now we're actually, the raw text that I refer to will be the second column that we have here. And that's why we're doing SMS1 in brackets. That is basically referring to the second column. So the actual texts themselves, whether they're ham or whether they're spam. So another part of data information is to look at if there's any missing values. Missing values in your data is obviously not good because it can reduce the accuracy and your precision, and it does affect, you know, how well your model is working. And so when this happens, the data set might lose some power in what it is expressing. It can lead to some biased analysis. And so in our case, we actually don't have any null values. But that's you know, not very commonly seen. So to identify which rows actually contain missing values, we will be using this isNull function. Again, this is a part of pandas. And so what we'll do is do PD, which is again referring to pandas, dot isNull. So we're calling this function. And then the parameter that we put inside this function is SMS, which is again our text data that we're working with. And what you can see is that if there are any null values, meaning, you know, there is no value, then it'll print out true. But as you can see here, that, you know, majority of these are false. And I did go right now, you can't see, you know, all the, you know, 5,000 rows printed out, but I did go through and there were no false values. So that means that, you know, they're all normal values. There's no missing values. So we were lucky in this case. The data was very complete. We didn't have to worry about any missing values. But there might be some data sets where there are missing values, and there's different ways to handle that. Sometimes you can fill in the values manually, depending on how much data you have, if there's a way to interpolate the data, or you might just simply remove that entire instance in the data set because you might be, you know, introducing some bias into the data by, you know, manually entering in, you know, synthetic data. So for the last part of the exploratory data analysis is just a basic visualization. And so for this, as I mentioned in the slides, we'll be using matplotlib and Seaborn, and these are both very commonly used libraries in Python, and they make it very easy. They're very you know, user-friendly. So there's, you know, tons of visualizations that you can do. There's a word cloud. There's you know, websites that allow you to make a word cloud very easily. All you have to do is just copy and paste all of your text, or you can just upload the file. So just our SMS spam collection file, and it'll print out a word cloud for you. But what we will be using here is actually printing out the length of each of these individual texts and seeing kind of a distribution of the length of each message. So before this, we actually want to assign some labels, because right now our columns in our text file have no labels. We know what they're referring to, but if we want to be able to do some visualizations, we actually need to provide some labels to these columns. So first we will be doing, as you can see in this cell, we have SMS.columns. And so that's in this dot columns, what we're doing is basically assigning these labels. So label and message. So label is basically, what is a label, ham or spam? And then the second column is the message itself. So I just, shortened it to MSG, but you can, keep it as any label as you want. This is kind of whatever is the most convenient for you, whatever makes the most sense to you is what you can assign as a label for that column. So now we run that, and now we have SMS.head, and this is basically, again, printing out the first 5 rows of our data set. Let me just print that out. And then lastly, what we actually want to do, what we want to visualize is the length of each of these messages. But right now, there is no information on that. So in order to do that, we actually have to do a bit more work. So first, we will actually be, again, how we did up here with assigning the label to the column. We want to add in another column and call this length, because that is the length of each of these messages. And then next, what we'll be doing is that the message is in this second column here. So we'll be doing SMS message, and the brackets help to refer to the specific column. And then dot apply len. So this function here is another very useful pandas function, and it allows you to compute the length of the any given phrase, sentence, whatever it might be. And so here we want to just we want pandas to go through each of these 5,000 messages and compute the number of characters in this message, and that's what's printed out in this column here. So once you do that, and now we print out the first 5 rows, and as you can see, it's now printed out the length of each of these messages. So you have 111, 29, 155, etc. And so lastly, since the whole point, we wanted to get a nice visualization of our data. So what we'll be using is actually Seaborn. And as you can see up here, when we were importing Seaborn, we imported as SNS. And again, how we imported pandas as PD, this is something that's very commonly done, where we just import it and give it a name as SNS, so that when we're referring it to here, we don't have to type out Seaborn, we just put in SNS, and the notebook knows what we're referring to. So we'll be using the dist plot, which is a specific kind of plot that Seaborn allows you to do. But we have to give it some information. So what we actually want to plot here is the length on the x-axis. On the y-axis is basically the frequency of that length. But we have to actually provide it this parameter so it knows exactly what we're referring to. So we wanted to print out the length for each of these messages and the frequency for each of them. So this is just one example of a very basic visualization that we can do. And there's far more that you can do, and I will be referring to some tutorials after we finish this implementation. There'll be some tutorial links where you can find out some other visualizations that people do. But I just wanted to give you one example of one of them. So now that we have completed the exploratory data analysis, we'll be going into some pre-processing. And this is a second step of our workflow. And so, as I said, the first step is noise cleaning. So we're going to be working on removing some white space, special characters, punctuation, etc. So first, we just want to take just a few random examples of our messages from our data set. And the way that we do that is we do SMS.sample. This is basically taking a random sample from our SMS data set. And then this fraction here is basically just going to be taking 5% of our data set. So now we run this, and this just gives you, 5% of the data set. It just gives you like a nice look. But as you can see here, there's like random punctuation marks. There's a lot of unrecognized characters. There's a lot of special characters, some white space. This is like randomly capitalized for some reason. And so we basically just want to go through all this, and we have this pre-processing step of normalization. So basically, this will help to take care of all the spacing and the special characters. So in order to do this, we will actually be, the first thing we'll be doing is actually transforming all of these words to lowercase. This is a very common pre-processing step that you can do. And so what we'll be doing is we'll be actually adding another column to this data set called lower. And so this lower data set will basically contain everything, all of the original messages, but everything will be lowercase. And so what we do is we say SMS lower equals, let's see here. I think I have, this might be a bit out of order, but so I might jump to the second step here because we actually have a column of tokenize that we're using here. Let me see here. Okay, so let's actually jump to the second step and then come back here. As I said, tokenization is actually how we construct the features. So this is where we're going to be using NLTK, which is a very popular package that's used for NLP. And so we will first be importing NLTK, and we actually want to use a specific package in NLTK called punkt, so PUNKT. So let's run that. And from NLTK, we actually want to import a specific library within that, which is called word_tokenize. So let me just let that run. It might take some time. Okay, all right, so that worked. And so as I demonstrated in the presentation, we kind of had this very basic tokenization, but I'll just show you how it's working. So we basically have, we are assigning this text. So text equals, hi, I would like to tokenize this sentence. And basically we call this function here, word_tokenize, on this text. So then basically, and we want to print that out and see what it looks like. So when we tokenize that, just give it a second to run. Okay, so now we have it tokenized, kind of how we had it in the presentation. So hi, I would like to tokenize this sentence. And as you can see here, it actually did tokenize the comma and the period. But for now, we're just going to let those be in as tokens that we can use. So now that we had, we demonstrated that in a very simple example, now we actually want to apply this tokenizer to our data set. So again, we'll be using the word_tokenize function. And so here, we'll be adding another column into our data set called tokenize. So basically that column will contain the original messages, but after calling the tokenizer function. And then we will also be adding in this message string because right now each of these messages are not identified as strings, but we want the tokenizer to be able to run successfully on our messages. And then again, we'll be doing .apply word tokenize, and then SMS.head will basically just print out the first 5 rows. Let's see here. Let's see what the error is. Okay, let me Sorry, just give me a second. Not sure why that called an error. Okay, so yeah, so there were a few changes I did make to this notebook in terms of the different steps. So I apologize for it being a bit out of order, but what we can do is send an updated version of that right after the seminar is over. But basically, this message underscore string is actually that's done in a later step. Typically before tokenization, there is something that we do before that. So I'm gonna just jump to that other step, and I apologize for it being out of order, but let me just jump down to the appropriate step, and then just so that you can see everything working properly. But we will send out the corrected version. So let me go down to here. So let's see. So this is actually from step 4 in the contraction mapping. In the contraction mapping, the main goal of this is to basically expand our contractions. So what you want to do is actually install and then import this library contractions. So the way we do any installs directly into Google Colab is we actually put this exclamation point in front and then pip install contractions, and contractions is the name of the library, and then after installing we then import that. So let me just run that cell. Okay, so that's successfully installed. And so now we will actually be adding in another column called no underscore contract. So basically we want to remove all these contractions by expanding them. And then the way we do that is we actually go into this message column, and a Lambda function, in simple terms, it basically is a very simple way to execute something over multiple rows. So what you want to do is actually go through every single row in this message column, and in here we're going to be calling the contractions package that we installed, and it actually has this function called .fix, and that basically will be expanding these contractions. And the input that it will be taking in is word. And so lambda functions basically work where first we specify, what is it iterating over, and then we say for word in x.split. So basically it knows that we're referring to this message, and basically for every single message in this, it'll actually be calling this contractions.fix. So let's run that, and then we'll see what the first 5 rows look like. And that's what it looks like. So basically you can see how, yeah, so here it says, nah, I don't think. Here it's expanding it to, nah, I do not think. So that's exactly what we wanted. We wanted the contractions to be expanded. And so here's where we're actually calling this message underscore string. So this is basically, we want to we convert this entire column no contract, we want to convert that back into strings so that it's usable again. So let me call this. So basically what we're doing here is we're adding this another column, message underscore string. And through this entire thing here, we're basically joining each of these individual tokens back into a single string. And we wanted to go over this column no contract because that's what we just created in the previous step. So now we look at the first 5 columns, and as you can see, message underscore string, now it's successfully taken each of these individual tokens into a single sentence. So now from there, let's actually go back to our original location. Let's see, so we did that. Let me go back up here. And sorry for going back and forth. So now that we have that part working, we can basically call our tokenizer on here. And as you can see, it's retained the original message, the length, the column that had no contractions. Then we have message underscore string is basically combining all of these individual tokens back into a single string. And lastly, we have this tokenized column. So now it's gone back and it's tokenized each of these individually. And that's what we originally wanted to do. And then let me just check something here. Okay, so now let's go on to our next step, which is spell checking. So for spell checking, there are several libraries and packages out there that we can use for spell checking. And we'll actually be using Microsoft's text block, which is very simple spell correcting mechanism. So you can install this again using the exclamation point in front here, and then pip install, and it's actually called Pi Spell Checker. So let's install that. Let's wait for it to, okay, so it's now successfully installed. And now let's move on to the next step. So now that we have it installed, we want to import the spell checker because that's what we actually want to use. And this is actually the snippets of code that I showed you in the presentation. And this is basically going through this, the sample text that we have here. We've basically just assigned it a variable called misspelled. And then we have spell.unknown, and this is the function that the spell checker has. And we basically inside here input just a few different words. And as from the presentation, we saw that happening was clearly misspelled here. So then basically we can go back in here and we implement this for loop. So first we can print out the most likely answer, and then we can kind of get a list of likely options. So the way that we do that is we basically do spell.correction word. So we're basically asking for this library to correct the misspelled word for us. And then the second option here is basically just to do a spell.candidates. So basically just giving us all possible options that are likely to be the correct spelling. So if you were to just run that, you can see that for the first thing that we have printed out here is the most likely answer, which is, it's correct. That's how happening should be spelled. And the second thing that we have printed out here is other likely options for what the spelling could be. But clearly this is the correct one that we want to use. So then we completed this contraction mapping step. And now let's go to the stemming and lemmatization. So as I said, we will actually be using lemmatization because it is typically a little bit more accurate. And although it does require additional steps compared to stemming, it is more accurate, and it is something that's typically preferred over stemming. So again, we'll be using NLTK. And we actually want to use this specific library, which is called Averaged Perceptron Tagger. So all you need to do is do nltk.download, and inside there is a specific package that we want to download. So let's just run that cell, and now it's been downloaded, so now we can use it. So here we will first be adding in some parts of speech tags. So we will actually be looking at the SMS no contract column. So this is basically where all the contractions have been expanded. And what we will be doing is do a dot apply. And then in here, you can see it says nltk.tag.pos_tag. And that's basically utilizing NLTK's function to basically apply these different parts of speech tags. And this is what I referred to in the presentation. It basically allows it to assign kind of a syntactic role to every single token that's in any given sentence. So let's now run this cell, and then might take some time because it actually has to go through every single message and every single part of that message and assign a tag to it. So it's expected that it might take some time, but let's just let that cell run. And And now we will be just doing, again, SMS.head, and that prints out the first 5 rows, just so we can make sure that we are, successfully doing what we wanted to. So as you can see here, it's assigned different parts of speech tags to each of these. And next, we will be doing the lemmatization. So NLTK actually has its own word lematizer. And the reason that we did the parse of speech tag here is because that lematizer actually needs these different tags to actually successfully work. So the package that we'll be using from NLTK is called WordNet. So again, how we have downloaded things in the past, we'll basically just do nltk.download and then specify this WordNet package inside. So let's run that cell. Okay, and now it's been downloaded. And so here is a function where that we have defined. So it's called get WordNet pause. And what it takes in is a tag. And these tags are basically the different parts of speech tags, as you can see here. And so this one is actually using just, a series of if statements. So here we have if tag dot starts with J, then return wordnet.adj. So what this specific block is saying is that if any given tag starts with this letter J, then we want to basically say that that specific tag is actually referring to an ADJ, which is an adjective in this case. And the rest of these if statements are basically going through that same logic. So basically, if a tag starts with V, then it is a verb. If it starts with N, then it is a noun. If it starts with R, then it's an adverb. And basically, this else statement that we have at the end is basically saying, okay, if the tag doesn't satisfy any of these conditions, so if it doesn't start with J, V, N, or R, then that means that it's a noun. And so in this case, obviously, this function is only covering, 5 different possible tags. And this can be expanded to cover more tags if you would like. But for simplicity's sake, we have chosen 5 possible tags. So now that we have defined this function, we want to actually apply this to our data set. So again, here we'll be adding another column to our data set called WordNet pause, basically just the different parts of speech that we have. And we wanted to look at this POS tags column because that's what we just did in the previous step. And then again, here we're going to be using a lambda function. And so what we wanted to do is to actually, this part here, get WordNet pause, is our function that we just defined. So we want to call that function on each of our POS tags. And we wanted to basically iterate through all of our POS tags that we just generated. So now let's call this function, and let's see, WordNet is not defined. Let's see here. Just give me a second here. Sorry about that. I'm just trying to resolve this issue. I am trying to import that because it looks like it's been installed but not imported. Let's see. Sorry for the delay. I'm just trying to resolve this issue. I think it should be working now. Okay, I think it's up and running now. Okay. Sorry, just give me a second. Okay. All right. Sorry for that. Yeah, so it was just missing the proper import statement. So we have nltk.download_wordnet, and we basically just want to do from nltk.corpus import wordnet. It basically didn't really know that we had installed it, but the import statement was missing. So now if we rerun that cell, let's fix that. Okay, and so now let's run this function that we have defined, and now let's call this function on our data set. And so that worked, and now we have this column that we just added with the wordnet pause. And so now we want to actually apply the word net lemmatizer using a list comprehension, and basically we're again going to be using a lambda function. So let's import that, and here we're going to be calling the word net lemmatizer from NLTK. And here we're again going to be going through the same process of adding another column at the end called lemmatized, and that's basically the result we get after calling this lemmatizer. And it'll be working on this column that we just added on, wordnet_pause, and we will be applying the lemmatized function that is part of wordnet lemmatizer, and we're going to be going through each of these tags. So now we have our lemmatized column, and that is our second to last step for lemmatization for pre-processing. And now we have our final step for identifying the stop words. So here, as I said, stop words are some words in the English language that are part of the sentence, but they don't really add much meaning to our sentence. And so therefore we want to identify these, and then we want to remove them. So in order to do this, we basically want to download the stop words library that's part of NLTK, and we actually have to specify the language to English. So let's do that. We're going to be doing import NLTK. Let's see. Just give me a second here. Sorry about that. Let's see. Okay. It was the same issue. So basically, after downloading stop words, we do from nltk.corpus import stop words. This was what was missing from this cell. And then here we're basically setting the language to English so that we get the appropriate stop words library. And so again, as we've been doing, we're going to add another column called no_stop words. And this is basically where we will be removing all the possible stop words, and we're actually going to be looking at the no_punctuation column, since that column actually has already been tokenized. And it's already been converted to lowercase, and the punctuation was removed. So again, we're going to be using this lambda function, which functions as a very neat and clean for loop. And here we're going to be iterating over all of the tokens that we have inside this no_punc column. And what we want to return is only the tokens that don't exist in the stop words variable. So let's run this cell, and let's see here. Okay, I believe this was from a previous step. So let me just jump up real quick. And I believe we did not run that cell completely. Okay, so I've actually gone up a little bit further up in the notebook. Again, sorry for jumping around so much, but the updated notebook will be sent right after this seminar is over. So if you go back up here, this is where we had actually, transformed all of the words to lowercase, and let's just call this here. And so now we have everything in lowercase, and this is after we completed our tokenization. And so then after this is where we actually went through and we're going to be removing all of the punctuation. So again, we'll be using a lambda function, which, kind of functions as this for loop. And so now we have our no punc column. And so that's why we were getting that error, because there was actually no column with that name yet. So now if we go back here, let's see, this should work now. So now we go back to step 6 in the stop words identification. And now let's run this. And so now it should be able to, it sees now that the no punc column is there. And basically we have now removed all of the stop words, and we have achieved all of the 6 steps of our pre-processing. And so now that we've completed the exploratory data analysis and we have completed the pre-processing, so now we're ready for the next steps in our workflow. But before we finish, a really important thing is to save your work. We went through all of this. We want to make sure that our work. So once we just have this one last cell that we have to run, and we can simply save it as a CSV file. So what we do is we take our original, we take our SMS data set, basically we use the .to_CSV. And this is just to save it as a CSV file. And what inside here, what we have here is actually the name that we will be assigning to our new CSV file. So let's just run that. And so now it is saved, and it should appear in our file system here. It might just be taking some time. But basically, that's the last step that we want to do for this implementation. And as you can see here, you see this SMS Spam collection.csv. And so now, using this CSV file, we've completed all of the pre-processing, and now we're ready for the next steps in our workflow. So that completes our implementation. And let me just switch back to the presentation, because we just have a few last slides to go through. Just give me a second here. Okay, so we have completed that. And so, so as I mentioned, here are just a few tutorials. So we kind of have 2 parts to, some homework for you to do on your own. Mentioned due to some, organization issues in the Colab notebook, we'll be sending out an updated version of it right after this seminar is completed. And here are just 4 different tutorials that were used for this notebook, and it actually goes through a few more steps in pre-processing and exploratory data analysis, some more visualizations, and then some of them use different data sets. And so I would highly recommend going through these tutorials. They're very easy to follow, very straightforward, and will definitely help you get a first step exposure into NLP. And then just as a second homework, here are some additional data sets. So as you know, we used this SMS spam versus ham classification data set, but here are some general data sets. So NLTK, which which we used quite a bit for our notebook. They actually have their own set of a variety of different data sets. There also is another data set from Google Blogger. There's some recommender systems data sets. And then we have some that are specific to specific NLP applications. So we have sentiment analysis. Yelp reviews is a very commonly used one. And then we also have a text classification data set, which is actually a Jeopardy data set. And these are all clickable links, so you can actually find links to those data sets. So that concludes the both the theory and the implementation part for this NLP 101. And if you have any questions, please join us on Slack. The links to the information for joining Slack has been shared in the chat. And please post any questions that you might have in the Help Me channel. So once you join our Slack, please join the channel that's Help Me. And me, along with other panelists, will be there to answer any of your questions. And we hope to see you next week. And so next week will be the week 2 of our 6-week series. And here we'll be doing a deep dive part 1. And we hope that all of you can join. And that concludes today's seminar. Thank you, everyone.